Okay, this is the addendum to lesson 5.5, specifically on Newton's method. So Newton's method is very interesting because we're using the derivative to help us approximate the zeros of a function, the solutions to the equation. So basically, we're looking for the x-intercept. So a very good idea of what is happening here is you have a graph like this, just a random function. And here's your equation here, okay? You're really trying to figure out what that point is, but you don't know what it is. So you venture a guess. You say, all right, I'm gonna guess. This is my first guess. And if I go up to that point on my graph is going to be x comma, that's gonna be x1 comma, f of x1, right? Because that's the x comma y value, okay? You take the derivative and you figure out the tangent line to that point, right? To that point and through all the way down. Assuming that, well, not assuming, but your tangent line is going to cross through the x-axis right here, giving you a point on the graph on this tangent line that is x2 comma 0. Okay? So first of all, let's ignore the x2 comma 0. Let's look at just the tangent line itself. How do we write the equation of the tangent line? So for the tangent line, you have your traditional y minus y1. So y minus y1, so f of x1, equals your slope, f prime at that point, m times x minus x1, right? We know then our tangent line is going to cross through this point right here, this x2 comma 0, because that will be the x-intercept that is a little bit closer to what we actually want. So we're going to plug that in as my xy value. So if I plug in my x value, this is x2, and my y value, 0, into my tangent line, I get negative x f of x1 equals f prime of x1, x2 minus x1, right? Okay, I'm going to solve for x2. I'll just show you in a minute why. So if I divide this over, I get negative f of x1 over f prime of x1 equals x2 minus x1. I add x1 over, so x1 equal x1 minus f of x1 over f prime of x1 equals x2. So the new point can be, you will get the new point by taking x1 minus the function evaluated at x1 divided by the derivative evaluated at x1. So that's your new point. Once you have that new point, now that's your new point, you do the same thing again. You go up, that is your point. From there, you find the tangent line. You see how my tangent line is a little bit closer now, right? And that will be your x3, and so on and so forth. So your x1, x2, x3, you'll get as close as possible to the actual 0 that you want, right? So the right-hand side, that's a proof of why this formula works. Now you can go back and rewatch it and see if that makes more sense, or you can accept that this is the formula, right? So we're going to use Newton's method to estimate the real solutions to this equation here, right? And so we have the graph here. We have the graph here to kind of help you estimate. And so the suggestion is that if you see this graph here, you see it's between 0 to 1, my 0 is between 0 to 1, we would say then a good guess would start at x sub 1 equals 0.5, right? So it's halfway, 0.5. It could be better. You could guess that it's 0.6, but it doesn't matter. It won't take that many more iterations to get to the actual answer, okay? So first thing I'm going to establish is first the f prime. The derivative of this is 3x squared plus 5. Second thing I'm going to establish is that my first guess is going to be 0.5. Okay, so x5. X sub 1 is 0.5. Okay, put it in the put it into the calculator. You actually have to use a calculator for this because then the decimals get bigger and bigger and bigger and bigger. All right, so to get x2, simply take x1 minus f of x1, so 0.5 cubed plus 5 times 0.5 minus 3 all over. Now the derivative. So you have 3 times 0.5 squared plus 5. Okay, put that in the calculator. You will get a very long decimal, 0.5652174. And apologies, there should be about 4 decimal places. We don't need 6 decimal places, but your homework does want 6 decimal places. Okay. right, once you have that, that's your x2. Okay, to get the next number, now you gotta plug, this is the fun part. You gotta plug this into here, here, and here. So if you're savvy with your calculator, you could definitely kind of rework it so you don't have to retype everything in. And make sure you're checking your work as you go along, because if you do this right, x3 will get 0.5641. And then I think it's 000, so you don't have to worry about the decimals. And then x sub 4, you'll see you get 0.5641, which is great, because then that's all we want. We want 4 decimal places. So these are, as soon as your two x values are exactly the same, then you have established that you have the accuracy you want. Of course, you can use your calculator to check your work and make sure that you are getting the approximation good enough. Because if you use a calculator to check, you can use the zeros, the second calc function, to find the zeros. So this is a very cool way to see how derivative is really applicable, because now we're using it in a different way. We're using it to help us approximate the zero, the solution. Okay. The equation next door, you can see that I have a 0 right on the spot of -1, so we don't even need to check that. This is the one we are trying to look for. It's between 1 and 2. So I'm going to say that x1, I'm going to start at 1.5, halfway. All right. That way our guesses are all the same. If you guess 1.2, then your numbers are not going to match up with mine. Although eventually, yes, you'll get the approximation. It's harder to check your work that way. Okay. All right. Don't forget to find your derivative. So f prime of x is 4x cubed minus 1. So again, same as the previous problem. To get my x2, I start with 1.5 minus, plug in the 1.5 to the 4th, minus 1.5 minus 2, all over 4 times 1.5 cubed minus 1. Put it all in the calculator. You should get x2 to be 1.375. Oh, this one's actually very exact. I rarely get that, but this is exact. So again, you're going to put the 1.375 back in here, oh, and here too. Sorry, I forgot to say that you got to put in the original one too, because you got to replace all your x values from before, right? All right, so check your work. Make sure you're doing this correctly, because x sub 3 should be 1.353777. Keep going, because you want at least a couple of the decimals. You want at least 4 decimals to match up, right? Okay, so then x sub 4 is 1.353210. And you'll see then by x sub 5, you get 1.353210. And that is pretty good. Okay? All right, make sure you're checking every single step. Should this happen to show up on a quiz or a test, I will be asking you to show me all the different ones in between, the x sub 1, 2, 3, 4, 5, until you can prove your accuracy. Okay? That's it.